Welcome back, everybody. In this module, we're going to learn about sequences and iterations. First, we are going to cover sequences. Then we are going to learn about ranges. Then we're going to cover iteration. How do we achieve repetition in Python? So we're going to learn about for loops, while loops, and then at the end, we're going to practice. All right, so that's our agenda throughout this module. Really very important module. It's really important to grasp all the concept covered in this module. So let's start. We're going to first go over sequences in Python. Okay, but before that, we are going to analyze why we need sequences. All right, so throughout this lesson, I'm going to take two sequences, S and T, of same type, and depending on the scenario, I'll be either picking a list or a string or a range. Okay, but S and T refers to two sequence of same type. Okay, just a heads up. All right, so let's start. All right, so we use sequences in real world. Okay, so we basically categorize objects into groups and can call them sequence. Okay, so let's go some examples. Days in a week. It's a category, days in a week. And if we put together, they are in a sequence. Day numbers in a week, like day 1, day 2, up to all the way day 7, or in a month or in a year. Students in a class is a sequence. You can categorize all the students in a class into one. So maybe it's a list, it's a tuple, okay, students in the class. Sequences numbers in mathematical progressions. We use patterns of numbers. They are also sequences. So now you can see that in real world, sequences are prevalent. So let's analyze why we group object into sequences. So it's basically to identify uniquely and then refer them collectively. Okay, so if it is this class, we can identify all the students in this class as a unique. So it's a unique identification. And we can refer them as well. So it's a class 131B collectively. Okay. We can apply common tasks. Like for example, if it is production, chain, and we can call the task labeling, right? So we can apply common tasks to entire sequence. Okay, so labeling, or we can sort it. There are many tasks that you can think of. Okay, of course, you can arrange them, order them, sort them. So those are the operations. You can also refer individual entities inside through a mechanism called indexing. Okay, so if we have a line of people, then we can refer to the person in the line using that number 5, right? So that's we call indexing. All right, so let's see how we take this concept in real world into programming. Okay, so in programming world also we have this concept called sequences. Well, simply we solve real world problem in programming. So we need to have that one-to-one correspondence. Okay. So in Python, we collectively call them sequences. Okay. And here are the list: strings, lists, tuples ranges. Binary data type has 3 types. There are sequences, and you can click over here and investigate them. And these are the types of sequences in Python. And we are going to go over all of them in this class. So the object inside a sequence, we call them elements or items. And throughout in this lesson, I'll be referring to these elements and item interchangeably. Okay, so we call them elements or items. So we can refer to a sequence as a whole and treat as a whole, or we can refer to an individual element as well. Okay. So elements, they are arranged sequentially. Okay. So it's usually a convention. So if it is a string, text string, we know that many programming languages, including Python, follows English. In English, we write a word from left to right. So that is the progression, that is the sequential arrangement when we follow in programming as well. So that arrangement is the sequential arrangement from left to right writing order of characters. Okay. So if it is a list, it is also the same. So when we write a list, we sort of follow either top to bottom or left to right order. Simply again following the English writing order. So in programming also, that is going to be the order. Okay. We arrange them sequentially. All sequences has elements in all sequence has an index based on position. Okay. So there are two ways of indexing, in particular to Python. So not all the programming language. Okay. So from left to right, the indexing start from 0 and all the way goes up to the length. Well, 1 less than the length of the sequence. So that's the common way. Pretty much in every programming language follows that rule. In addition to that, in Python, we also have the concept of negative indexing. Basically, you can follow the reverse way, right to left, and index as well. That indexing start from -1. So 0 is already taken, right? So started from -1 and all the way goes up to negative length. Okay. And we can use the index operator to access element. Okay. So so this is how we write it. We have the sequence S. We use the index operator, which is the square bracket, and inside square bracket we put the index, and this way we can access the ith element of sequence S. Okay. So let's go to Jamboard and see how this is possible. Okay. So I'm going to create a simple sequence, a text sequence is, and that equals to Python. Okay. So I'm going to write this a little bit broader, okay, and separated the letters so that I can analyze this easily. Okay. Now, okay. So now, so negative positive indexing start from 0. So this is the 0. So I'm going to separate these lines, each character like this, and this is the 0th index. This is the first, second, third, fourth, and fifth. Notice the length of this word is 6, and the last index is 1 less than the length. Okay, so this is 0, first index, second, third index, fourth, and fifth index. From negative indexing, excuse me, on negative indexing, we start from the rightmost end and we go towards left. Okay. In positive indexing, we start from leftmost end and go towards right. Okay. So this is the way we follow. Okay. So in negative indexing, we start from -1, -2, -3, -4, -5, and all the way up to -6. Okay. So this one is -1, -2, -3, -4, -5, -6. So that's we proceed from right to left. Okay. So to refer to, let's say, letter P, we can simply say, I'm going to take over here S0 is equals P. Okay. And it's also equals S minus 6. Okay. All right. So let's go back to PyCharm and just quickly test this out. We're gonna go back to our lesson. Okay. All right. Okay. So depending on the sequence type, the sequence may have different types, or it may have just single type. For example, if it is a string, you know that a string can only have characters. So individual characters also is a string in Python. So a string can only have strings inside in Python. If you take a list can have variety of types, many different types inside. So there's no restriction on list to have a certain type. Okay, so depending on the sequence type, element can be different type or same type. Okay. All right. So there are two major types of sequences. Okay, so we call them like sequence mutability. So depending on the sequence mutability, there are two different types of sequences. One is mutable sequence, in which once formed, it can change. And list byte arrays are examples of mutable sequences. Python list and byte arrays are examples of mutable sequences. The other one is immutable. So once formed, you cannot change it. Okay. So mutable means such like ability to change, that is the mutation, right? So the famous word for genetic mutation. So that's the meaning. So mutation means prone to change. So mutable means prone to change. So immutable means not prone to change, so can change. Okay. Strings, tuples, ranges, and bytes are immutable in Python. Mutable sequences, again, once formed, you cannot change them, and list byte arrays are examples. And in a mutable sequence, item assignment is legal. What does that mean? So imagine the S I exist. Now, if you want to change it, change Si, we can reassign the new value to Si. And that's a change. So this operation is legal in mutable sequences. Okay. So let's check this out. Okay. So I'm going to go over here and create my mutable sequence. Let's say S. It's a list, simple list. We're going to learn about list pretty soon. But think of this as a list, just a list of two numbers. Okay. So now I have the list. Now I'm going to change it. So S, I'm going to pick, let's say, the 0th element, and I'm going to change it to 5. Okay. All right. Now I can print my list S. I can print it before and after both. Okay. All right. So let's quickly run this. Okay. So I got before printing 1, 2, and after printing 5, 2. So it's indicate that I changed it. Okay. So that means it's prone to change and it's a legal operation. You can do that. Okay. So what if we what if we try to change something that is not existing? Okay. And we can try to change, let's say, element 3, which is not there. So that is the case, it's an index error. So we will get an index error when you try to do when you try to change an element that is not existing. Okay. All right. So mutable sequences doesn't implement hash built-in method, and that's the key difference between mutable sequences and immutable sequences. Okay. So mutable sequence doesn't implement the hash built-in function. So if you try to get the hash value of this S, okay, okay. So I'm gonna block this for now, and we get an error. Okay, so it's a type error, unhashable type. So mutable sequences are unhashable. Okay, right. So go back to our lesson. So we're gonna learn more about mutable sequences like list in depth later. Okay. All right. So we're gonna briefly go over immutable sequences now. Okay. So once formed, we cannot change them. So examples are strings, tuples, ranges, and byte types. So item assignment is illegal in immutable sequences. Okay. So let's try that out as well. So I'm going to create my immutable sequence. Okay. So S equals, now let's say Python. Okay. I'm going to try to change, let's say, the first letter into small p, right? And I'm going to try to run this. Okay. And let me just unblock, sorry, block over here. All right. So now, So it's again a type error, and it's saying string object doesn't support item assignment. Okay, so it means you cannot change it. Okay, string object doesn't support item assignment. Okay, it's a type error. Okay, all right. So it's a type error to try to change an immutable object. So unlike mutable objects, immutable objects are hashable. So let's try that out as well. So hash method returns the hash value of the thing that we pass into it. So it's a number, it's just a number. So let's try to pass P. So S, let's say S, and print it. So right, so you have to block this. All right, so we got this number. See that? It's an integer number. It's the hash value. Okay. I will learn about hash values later in the class too. Okay. In detail. So for now, you can think of it's a unique number that represents this S, unique integer number. All right. All right. So moving on. So we're going to learn about immutable objects in detail as well, like strings and tuples. Okay. All right. So the core idea of this lesson is to identify and understand this common set of operations that belong to all the sequences. Okay. So it is really very important that you understand all these operations because these are common to all the sequences. So therefore, I will not be going over again and again when we encounter specific sequences like list and strings, tuples, bytes, okay, or ranges, okay. So the reason is that we can commonly study them, and it's really good to do that way as well. Okay, so that's why I have decided to go over first this common set of operations belong to all sequences. There are minor differences, special situation, we'll see them when they arrive. Okay, so let's find out what are these common operations to all sequences. Okay, so here are them. So I'm going to list them one by one. Okay, we can test the membership. You already know what the membership test operators, right? In and not in. So you can test the membership of an item inside in all of these sequences. Okay, so membership test X in S, and it returns true if at least there's one X inside S. So that means basically there's at least one item inside S that is equal to X. Otherwise, Python return false. Okay. So let's check this out real quick. So it's slide number 9. Okay. So I'm going to take gain S equals, let's say Python. Okay. And I'm going to test the existence of O inside. So, okay. So print, right, letter O in S. Okay. All right. And there's no error, so I can run this. All right. So I should receive true. Okay. All right. So if we try to pick something that is not existing, let's say like letter Y. Oh, Y is also there. Let's say C. All right. So, and we get false. Okay. All right, so let's move on. So opposite of that is not in. Okay, so if the item is in, iterator will get false, otherwise we'll get true, because not in is the it's complete opposite of in operator. Okay, so you can test this out right here. Okay, so we can test both together like this, not in, and I'm expecting false here. I'm expecting true here. Okay, all right, so run it again. Okay, and false, right, because it's in there, so not in is now not true, right? So it's false, and not in is now true because C is not in there. Okay, all right. Moving on, concatenation. Okay, so if the two sequences are same type, we can combine them, concatenate them. Okay, for that we are going to use the plus operator. Okay, so string concatenation in Python achieved through the plus operator. Okay, and in other programming languages we call this, especially in C++, operator overloading. Okay, so in Python we don't use that phrase that much, but it is a keyword in programming. So we have this math operator we overload with different but related functionality, adding two strings together, so summing up two strings together. Okay, so it's a concatenation. All right, to use the plus operator, same precedence applies. Okay, same mathematical numeric precedence applies to plus as well. Okay, and this operation is inefficient, and you can check here there are other alternative ways to achieve concatenations. Okay, so let's check this out. Okay, so we are in the same slide, so I'm gonna go over here. So I'm gonna get a different t equals code. Okay, all right, so then now I'm going to add them up. Okay, so okay, all right, so let's say print s plus t. Okay, so I'm going to put a space in front of this so that it will be separated by a space. Okay, so I got Python code. Okay, so now let's check this statement over here. Same precedence apply. So how do we test that? So we need another separator that has a different precedence, and we're going to use both concatenation operator, which is plus, and that operator in combination, and see it adheres to the rules in precedence. Okay, so what I'm going to do is I'm going to test. Now I have this S plus T. I'm going to test the membership of this S plus T with a letter inside. Okay, so let's pick it like this. Okay, so I'm going to print the whole thing. Okay, so it's Python code. Okay, so let's pick this letter carefully, right? It's Python code, and I'm going to test for some letter that is not in this part but in this part. Okay, all right, so let's go for letter D. Okay, so right, so D in S plus T. Okay, so that's what I'm going to test. So this is my expression. This is my expression, and it has two operators. What is in, and this one is plus. So plus has these two operands, and int has these two operands. Okay, but we know that we are going to consider from left to right order, but if the operators are different in precedence, then the the operator with highest precedence take precedence, right? So that means the expectation is Python should do this first and then do this. Okay, let's see that if that is the case. Okay, so if it is otherwise, Python will do this first. Okay, then it's something we should expect something different, because this S in Python, so D is not in there, so this evaluates to false. Okay, and false plus this one, which something is true, this should evaluate to basically um, either an error or something related to a string T. Okay, so let's see about that. Okay, so we run this. Okay, so we get the answer true. Okay, so that means first we did this, we got Python code now, and D is in code, Python code, right? So it returns true. Okay, didn't return anything else. So that is to indicate that, okay, so in string concatenation also same precedence apply. Okay, so let's move on. And we can, of course, get the length of the sequence using len built-in function. Okay, and this is really efficient function. So every sequence object has this length as an internal parameter, and it's gonna form as we form this the string or the list or in any sequence. Okay, so upon addition or removal, it's going to get updated as well as an internal variable, and length built-in method access that variable and gives out the list, gives out the length of the sequence. It doesn't calculate the length. So if it has to calculate, then it has to go over all the elements and count them, right? So it's an expensive operation rather than accessing a value. Okay, so it's really important to remember that length s operation is a single instruction in the CPU. Okay, so it basically access the value of the length inside the sequence and then give it to us. Okay, all right, so let's print the length of s. Okay, so len s, and I'm expecting 6. I have 6 characters here. Okay, so all right, I got 6. All right, so let's move on. Repetition. Okay, so multiplying by a number or that many number of repetitions. So in Python, we use the multiplication operator for repetition, and you can write it either way: your sequence times the number or number times the sequence, the same thing. Okay, and it returns new sequence, and then in concatenation also we're gonna get a new sequence. Okay, so it's equivalent to basically adding s to itself n times. Okay, all right, so if n equals 0, we're gonna get empty sequence. Okay, so let's, as we go on, let's try this out. So it's slide number 10. Okay, so I'm going to use s equals code. Okay, let's just get a list. Okay, 1 and 2. Okay, and I'm going to take, I'll explain later why. Take it like this. It's a list of lists. So I have this outer list and there's inside, I have another list. Okay. So when this is the case, okay, so let's say I multiply this by 5. So print, so say S2 equals S times 5. Okay. And let's print S2. Okay. All right, so run this. So, excuse me. So we got this one. Okay. So this is the outcome. See that it's a repetition, right? Okay. So if n is empty, so if you write like this, let's write it new. Okay. So if n is 0, we get a empty sequence. Okay. It's not an error. Okay. And it, again, like the way we had plus operator, the multiplication operator has this also has the same precedence as to numeric. Okay. And we can also test it out the same way we did right here. Okay. Same way we did right here. We can test it out as well. Okay. All right. So if n less than 0, that also makes n equals 0. And again, it's empty list. Okay. So let's quickly check this out as well. So again, these are not errors. These are just the way Python design. So I'm going to multiply by -5, and I'm expecting again an empty string, empty list in this case. Okay. All right. So same with the strings as well. Okay. So moving on. So this is really important to understand. So these items inside is, they're not copies. These are not copies. These are referenced multiple times. And that's why I uh, took this way of a list to show you this. Okay. So there are several ways to check this out. Okay. So one is we can use the ID function. Okay. So every object in Python, we learned that every object in Python has this ID function, the identity function. So you can use it and verify the identities of each of these sublists. Okay. All right. So let's do that. And we can also um, verify the size of it as well, size of the entire um, list as well. Okay. So the reason Python do that is simply to optimize the memory. Okay. So we know that this may take more than 8 bytes of memory. We know that one memory address, memory reference, is equal to 8 bytes. Okay. So if we use only reference to refer these values, then we'll basically save memory. So let me try this out in our Jamboard. Okay. So, I'm going to get a new page. Okay. So let's say let's increase to this 100%. All right. So I'm going to take so this is my list. Let's say S equals, it's a list of list. Inside there's another list, 1 comma 2. Okay. We will learn about a list of lists in detail later in our list lesson. Okay. So now I'm creating S2. Okay. So I have this likewise, okay, and then all the way up to I think 5 elements, right? So instead of copying this into each of these elements, basically what happens is like this one of these element refers to this. Okay, so all 5 elements refers to this value. So there's no individual these elements. There's no, they don't exist. Basically, instead we have 5 references exist, and this just this value. Okay, so that way the size of memory is going to be like 5 times one of the size of the reference, which is 8 bytes. Sorry, 8 bytes. Excuse me. Okay, so bytes. So plus the size of this. Okay, so size of original. Okay, so that way it's just not 5 times the size of this, it's this plus 4 times the size of this, right? So you can see that it's actually less memory, it takes less memory compared to copies, right? So that's the whole idea. So it's that's why Python does this, to optimize memory. Okay, all right, so that's a big deal actually. So imagine you are copying like 1,000 times, and I'm going to save a lot of memory. Okay, all right, so let's go back to PyCharm and prove this. Okay, so it's slide number 10. So we're gonna go over here again. So I'm going to block this. Maybe I'll take this again. Okay, so what I'm going to do is I'm going to get the S. So let's do it this way. Well, I'm going to first try this way. Okay, so S, I'm going to get L1 is this. Okay, so it's just a simple proof. Okay, and this is inside L1. Okay, so all right, so let's run this again and then print S2, and then just to verify it's the same. Okay, all right, so okay, it's the same. So I got the same result. Okay, so now I'm going to print the ID of ID of L1. Okay, all right, so let's print that. Now I'm also going to compare the same ID. Let's pick randomly any of these elements. We know how to pick element, right? So this is 0th element, 1, 2. Let's say third one, 1, 0, 1, say 2. So I'm going to pick S2. Let's say third element and the ID of it. Okay, identity function of it. Okay, I'm checking whether they are equal or not. Okay, all right. All right, I got true, right? So that means basically, right? So it's true, their identities are same. That means both this 0, 1, 2, 3, this, and right here L1 has the same identity. If two objects has same identity, basically they are both referring to that single value. Okay, so that is the proof that okay, so all of these values, you can check all of them and they are equal, referring to, in this case, this L1 value. Okay, so they get copied. Okay, so this is really a little bit tricky to understand. Spend time on this. This is a problem that haunts novice as well. new programmers, okay? Because they simply think this is a copy, it's not, and then they try to change something, and all of a sudden everything going to be changed, right? So the reason is, if you change this, for example, if you change this is also going to get changed, okay? The the, the repeated list also gonna get changed, okay? So for example, if I change L1, let's say L1 1 equals to 5, okay, and I'm not going to redo the repetition. Now I'm going to print S2 again, and you can see that S2 also going to get changed. Okay, so run this. Okay, see that? We only change L1, but change has gone into the repeated list as well. Okay, this is this is another proof that okay, they are references, not the copies. Okay, all right, so let's move on. There's an exception though. So we said these are all common operation to all the sequences, but only for ranges we cannot, ranges don't support repetition or concatenation. So it's an exception. Okay. So basically the idea is obvious, right? Because ranges, when we see in shortly, ranges are only numeric sequences. So if you, according to a specific criteria, okay, so ranges are little bit specific sequences. They're numeric, and the criteria inside the range is also specific. So if we try to support repetition or concatenation, we're gonna basically ruin that criteria. That's why Python doesn't allow repetition and concatenation on ranges. Okay, so we can test this out as well. Okay, so let's create a range. Okay, so to create a range, I'm going to use range function. Okay, range, simple range, just 5. So if I print this, okay, so s equals this, and let me just quickly excuse me. Simply say print s. Okay, so let's just run this first and see our range. Okay, so it's a range object. Okay, all right. So if I try to multiply this, like 5, right, I will get an error. Okay, so it's a type error, unsupported operand for type range. Okay, so this is not supported. That's what it means, unsupported operand. Okay, all right. So ranges we cannot repeat, or we cannot concatenate two ranges. Okay, all right. Moving on. So we can access, we already saw this, we can access the ith element of of a sequence if it is exist. Otherwise it's an index error. We can also use negative indexing as well. Okay, so let's quickly test on that. So I'm going to block this because it's going to break my code. So let's take a range object. So s equals range 5. Okay, range, let's say 5, and I want to print s fourth element. Okay, so well, I'm going to change this because we haven't gone over in detail. So I'm going to change it to Python. Okay, let's say code. Okay, so I'm gonna get the third. Okay, and print that. Okay, so I get E, the last. So 0, 1, 2, 3. So third element is E. It's the fourth element, actually, third index. Okay. So if I try to access like this, then I'll get a index error, string index out of range. So I'm trying to access something that is not existing. Okay. So you can go for -4 and I'll get a value, okay, which is going to be C, letter C. Okay. So this is -1, -2, D is -2, O is -3, C is -4. Okay. All right. Let's continue. So we call this random access because this can be any number between 0 to the up to 1 up to the length. If it is positive indexing, 1 less than the length. If it is negative indexing, negative length. So we can access any index between 0 and that number. Okay, so we call it random access. In other programming languages, we call them array random access. We generally call them random access. And this operation is a single CPU instruction, and it's really important that you understand that. Okay, especially in data structures and algorithm class, you're gonna get this. You will hear this more often. Okay, so this operation is a single CPU instruction. Okay, all right, and in Python, it's basically single virtual machine instruction. Okay, because Python runs code in a virtual machine. Right. All right.